calculate the pH, we take the negative log of the hydrogen ion concentration. So how do we know that? Well, for strong acids, they ionize 100%. So if I have 0.01 molar HCl, that's a strong acid. That means that HCl, I'll do it, plus water, will yield H3O plus Cl negative. 100% of the ionization. The K of this is so big that basically products are all that exist except for a few little bit of reactants just to maintain the equilibrium. So that means that essentially the concentration of hydronium ions is equal to the concentration of the acid because it goes almost completely to product. So what am I saying here? 0.01 molar H plus concentration. These are equal. So how would we find the pH of that? Well, negative log of the hydrogen ion concentration. What do you guys know your logs? 1 times 10 to the,
Is it 2, the pH?
right? 1 times 10 to the negative second. 1 times 10 to the negative second. Or you could sit here and go, who was that, Noah? Is that you saying it? Good job. So if we take a look here, clear, negative log, 0.01, boom. Nope, close. Did I do that right? 2, sorry, 2, not 1 times 10 to the negative second. This is 1 times 10 to the negative second. So if we take the negative log of that, I got confused there for a second. We take the negative log of that, that is 1 times 10 to the negative second. So if we take the log of that, that means we pull down the place value, -2. And then if we put the negative sign in front of it, that means we get rid of the negative, which makes it be 2. So the pH of 0.01 is 2. So 1 times 10 to the negative second is what that is, right? When did you guys learn logs? I made this up. You know, I make numbers up all the time. So 1 times 10 to the negative second, when you take the log of 1 times 10 to the negative second, you would get negative what? 2. And then if you take the negative of the negative 2, you would get 2. So the pH equals 2. Do. So let's try a few of those. Just to make sure, go to one page, page 6. These are the hydrogen ion concentrations, 1 times 10 to the negative 6. What is the log of 1 times 10 to the negative 6? 6. But it's -6. So if we take the negative of the negative, then it becomes positive. Page 6. Yep. So we have 1 times 10 to the negative third, right? So if you take the negative log of that, what do you get? -3. If you take the negative of it, you get 3. So 2.2 times 10 to the negative fourth. Probably can't do that one in our heads, can we? What should it be, though? We know it's going to be between 3.
A little smaller than 4.
Yeah, it's going to be smaller than 4. It's going to be between 3 and 4. The greater this gets, the closer to 3 it is, right? So negative log 2.2 times 10 to the negative fourth. So we have 3.66. You know the first day is always very easy. Let's see. So what's this one going to be? This one's going to be between what and what? No, 11 and 12. Because it's negative log, right? We take the negative log, 7.8 times 10 to the negative 12. Since it's high, it's going to be closer to 11, right? So it's 11.11. Let me ask you this. Is this an acid or a base?
Base.
You were talking about this one. You were right. That is a base. I was pointing at this one. Is this an acid or a base? Acid.
Acid.
This. Acid. This. Acid. So is that easy enough? Neutral. Wawa, like Philadelphia. Now here is where it gets hard. For all practical purposes, the prepared concentration, like I said here, of a strong acid is equal to the hydrogen ion concentration, except for sulfuric acid. Why is sulfuric acid going to be higher? The hydroxide, the hydrogen ion concentration is going to be higher than the concentration of the acid. If I have polar H2SO4, it's going to be higher than 0.1. The hydrogen ion concentration is going to be higher than 0.1 because it is
Byproduct.
diprotic. Because there's two H's in H2SO4, right? Let me ask you this, smarty pants. What if it were triprotic, like phosphoric acid? Would the concentration of hydrogen ions be greater than or less than the molarity of the phosphoric acid? If we have H3PO4, phosphoric acid, would the hydrogen ion concentration be greater than or less than the molarity of the acid? Triprotic.
Greater.
Problem here is that phosphoric acid isn't what type of acid? It's not strong, which means we would not get 100% ionization, right? Because you have the 6 strong acid memorized, don't you? Of course I did. Of course I did. You remember that they exist though, right? Yeah. The 6 strong acids that you're supposed to memorize. Yeah. So if we take a look, because phosphoric acid is a weak acid, there's only a fraction of those molecules that undergo ionization. So for these acids, it's safe to say that the hydrogen ion concentration is less than the concentration of the acid. So we use this formula. Let me show you where this formula comes from. So let's take, for example, HF, hydrofluoric acid. You do not want hydrofluoric acid on you. And if you want nightmares, look up hydrofluoric acid incident and face. Disgusting. Hydrofluoric plus H2O. H3O plus F negative, right? The problem is if we look at the equilibrium constant, Ka, we have, I'm just going to change it to H plus because it's less writing. Remember, it is the same thing as that. And F negative, why am I not going to put water on the bottom of this? Because it's a liquid. No, don't penalize people like that. So if this is our equilibrium, right? Everybody can agree products on top, reactants on bottom. This is our equilibrium, right? We're good with that. Is it? Can you see that okay? Or does it need focus? Can't use them. We said water is what? A liquid. So if I put water in there, what's it going to be? 1, right? Yeah. That's better. So if we take a look, let's rearrange this equation and solve for H plus. What are we going to do to both sides first? Multiply by the concentration of HF, which is the molarity of the acid, right? Right? And we know that for every 1 H3O plus that forms, we will have how many F negatives? 1. So the concentration of this and this are the same. So let's make that x squared. Because we don't know what this is. X and x, that would be x squared. So if we want to find x squared, what do I have to do to both sides? Square root it. That gets rid of this. That gives me x. And what did I say x is equal to? It's also equal to the H plus concentration, right? So what does the hydrogen ion concentration equal to for a weak acid? It equals the square root of the concentration of the acid times the acid equilibrium constant. So you can do the math from the equilibrium math that we did last unit, or you can memorize this formula. The concentration of the concentration of the hydrogen ion equals the comma, the square root of the comma. Comma, constant molarity acid. Comma. I'm just made it up. You can't spell what? Comma. No, you don't know what a comma is? That's an ancient Japanese weapon, like a sickle on a nice wooden piece. So that's up for you to memorize, like you guys have the acids memorized, right? Yeah, yeah. Arrhenius concept. You should play Ghosts of what is it? Zumi or whatever. Zuma on the PS5. What? John knows, right, John? Yeah.
No, what?
The Ghost of Tsushima.
Oh, yeah, I love that game.
Yeah, see? Yeah, doesn't have PS5, John.
Oh, that's tough.
Arrhenius concept for bases. The Arrhenius concept for bases. Any chemical which produces hydroxide, right? Well, this is going to really throw a wrench in your party because there is something called the POH. The POH is the negative log of the hydroxide ion concentration. And for strong bases, the base undergoes complete dissociation. So the concentration of the hydroxide ion is equal to the concentration of the base. For weak bases, they do not undergo complete ionization. So again, the concentration of the OH negative is equal to Kubner, the square root of Kubner, right? That is also an ancient math. So there we go. So the pH and the POH relate because if we add the pH to the POH, we get 14. Yep. Oh my gosh. So check this out. This is page 6, dude. Determine pH if the OH is this. Well, if I take the negative log of this, what do I get? 7. So that is the POH. So what is the pH then if the POH is 7? Acid or base? Neutral. What is the POH of this? 11. So the pH equals 3. Acid or base?
Acid.
Acid. We just lost somebody here. We lost 2 people. If the pH equals 7, it can be many, many substances, not just water. But the pH of water at 4 degrees Celsius, I believe, the pH of water is 7. Okay. Yep. But the weird thing is the pH of water may be higher, but the actual number of hydrogen ions plus the number of hydroxide ions is still equal. Different day. Yeah, Brody. because we are given the hydroxide ion concentration. Right? To determine the pOH, if the hydrogen ion or hydroxide ion concentration is 1 times 10 to the negative 9th, what is the pOH? Not
-9.
space. Acid. Because this is the pOH. Right? So the pH 7, if it's less than 7, it's an acid. Greater than 7, it's a base. pOH 7, less than 7 is a base. Greater than 7 is an acid. Because they were not changing the chemical. If the pOH is 9, what does that make the pH? And we know a pH of 5 is an acid. So if you're in doubt, you know the pH stuff better, find the pH of it. pH of 16. Something's messed up. Yeah. There are very extreme circumstances where you could have a negative pH or one that's above, but it doesn't happen very often. Last thing. Water ionizes itself. If we add H2O to H2O, we can get H3O plus and water. OH negative. What's that, last semester or this semester? Water. So that is the self-ionization of H2O, right? That's the self-ionization of H2O. If we take a look at this, for every H3O plus we get an OH negative, right? We find the pH to be 7, so that means we have 1 times 10 to the negative 7th for our concentration of hydrogen ions. The pOH is also 7, so we have a concentration of 1 times 10 to the negative 7th for the concentration of our OH negative. If we multiply these together, we get what's known as the water constant or the equilibrium constant of water. Do you guys know how to multiply numbers like this? 1 times, what do you do to these guys? You add the exponents, so it's 1 times 10 to the negative 14. Right? So that is the equilibrium constant for water, or what we call the KW. Is this a big number or a very small number? So if I have a glass of water, is it mostly H2O or is it mostly H3O plus and OH negative? Right, because reactants are favored with with much less than 1, or well, with less than 1 for the K the constant. So, in review, we now have these 4 formulas, right? And if you are more of a graphic learner or whatever, a visual learner, we have this box. So last night at the laboratory, you had some columns that you did not know, one being the hydrogen ion concentration. But you used the pH meter in order to find the pH. So if we take, instead of the opposite mathematically of negative log, it is the anti-log. You know this because whenever I said 1 times 10 to the negative 3rd, you said, okay, the log of that is 3, negative the log of that is, I'm sorry, the log of that is negative 3, negative the log of that is 3. So what is the opposite of that? Well, it's taking 10 to the negative of the pH. Boom. So that goes from pH to hydrogen ion concentration. So what is the pH of the Sprite using the meter? What is the pH of anything using the meter? Somebody with a lab out? So it's 3.67 is the pH. So I hit that second button and then the log button. Negative, what'd you say, 3.67? 3.67. So that means that the concentration of hydrogen ions in there is 2.14 times 10 to the negative 4th. That's what you would write on the the thing for the hydrogen ion concentration of Sprite. Now, how do I find the hydroxide ion concentration of that? Nope.
1 times 10 to the negative 14 divided by that.
I use the water constant because this times this equals 1 times 10 to the negative 14th, right? That times that equals 1 times 10 to the negative 14th. So if I take 1 times 10 to the negative 14th divided by the number I just got. So answer, that was it, right? So I'm going to take 1 times 10 to the negative 14th divided by that answer. Boom. There is the hydroxide ion concentration. 4.68 times 10 to the negative 11. That is the OH concentration. What if I wanted the POH?
Negative log of that.
I would negative log this. That's why that square allows you to go all the way around circular. Because if I wanted the pH and I had the POH, I would take 14 minus the POH and I'm back to pH where we started. There you go, guys. I would like for you to get through the laboratory. I think it's due Monday. If you would get through 6 and 7 tomorrow, I will tell you that you have to practice these. This is just like that solubility product constant. If you didn't practice it, it looked hard on the test, even though it was quite easy. You know, we only spent 1 day on it, and I think that was that digital day where I gave the note. So this is something that you've got to sit there and go through and figure out in your head. You can watch either of the videos. We also recorded period 5-6. It has many, many less interruptions than this class. Many less interruptions.